In this video, I'm going to talk about estimation and prediction for the simple linear regression model. So we're going to use the same example we used before with pizza restaurants. And we've fit the model and we've done a hypothesis test for the slope. And so now we're in a position where we want to use the model to estimate or predict. And there's a difference between those two things. So let's talk about estimation first. So what we're going to imagine is that we're thinking about restaurants that are located near campuses with student populations of 10,000. Okay, so we could think about a whole series of such restaurants in kind of medium-sized college towns. We would like to estimate the quarterly sales for those restaurants. So the way that we do that is to estimate what y would be based on our simple linear regression equation. And so that's y hat that we talked about before. So down here, I've got my value of x that I want to use, which is 10, and then y hat, that's what I get if I plug 10 into my regression equation. So 60 plus 5 times 10 comes to 110. So $110,000 is what we predict for our quarterly sales for restaurants that have student populations of 10,000. So this is the estimate of the average quarterly sales for those restaurants. And that word average is very important here. So we're thinking about restaurants in general with student populations of 10,000. What would we estimate the average quarterly sales to be for those restaurants? Okay, so that's our estimate, but there's some error associated with that estimate because we've estimated a model, but it doesn't tell us definitively what sales, what average sales would be for those restaurants. There's going to be some error in there. So the usual way of addressing that is to put an interval around our point estimate. So we do that with a confidence interval for the mean. And to calculate that, we have to use a standard error. So we're going to call that SY hat. And the formula for that is given here. So it uses numbers that we've used before, uses the value S here, which was the standard error of the estimate, or the regression standard error. And then it uses the mean of x, and it also uses the sum of the x minus x bar squareds. So put all that together in the formula, and we come up with this number here. Tells us the estimation standard error. And so if we combine that estimation standard error with a critical value from a t-distribution, then that will give us a margin of error. And then we can add and subtract that margin of error from our point estimate to get our interval. So that's what this part does here. t.inf.2t is going to calculate the right critical value, multiply that by that standard error that we just calculated, the standard error of estimation. And then if we subtract that from y hat, we get our lower bound. And if we add it to y hat, we get our upper bound. So we're 95% confident that the average quarterly sales for restaurants that are located with student populations of 10,000 is between $98,583 or $98,583 and $121,417. Okay, so that's estimation. Now let's think about prediction. So prediction, it's actually a little more challenging because now we're focused on an individual restaurant. So a specific restaurant in a specific location with a student population of 10,000. So the sales there, it's a lot harder to predict that specific sales for this individual restaurant than it was to estimate the average for restaurants like this that have 10,000 students nearby. If we're trying to predict for an individual restaurant, it's much harder, and consequently, our interval has to be much wider. And it's wider because the standard error for prediction is a larger number than the standard error for estimation. And mathematically, the reason why it's larger is there's a 1 plus inside this equation that does not appear in this equation. Okay, and so it's that extra 1 that's in here that makes all the difference. So you can see when it's calculated, otherwise the formula looks the same, but that extra 1 in there makes this number much bigger than this number. But then we form the interval in the usual way, get a critical value from a t-distribution, multiply by the standard error to give us a margin of error, subtract it from y hat, and then to get the lower bound and add it to y hat to get the upper bound. And you'll see that this interval much wider than this interval. And we're 95% confident that quarterly sales for this specific restaurant in this specific town with a student population of 10,000 people will be between $76,127 and $143,873. Okay, let's see how Excel stat presents this material. Okay, so we'll get our linear regression going again. And we want to do prediction at x equal 10. Okay, hopefully this will work. I haven't tried this yet, so we'll see. Let's make sure I don't need to do anything else. Okay, it might ask me for a label here. Let's see. Nope, looks like it's good. Okay, fingers crossed. And let's just make this a little bigger so we can see. And let's see if we can find the estimate and the prediction. I should have tested this out before. Okay, maybe. Oh, here we go. Phew, that's lucky. Okay, predictions for the new observation. So we have a population of 10, and here's predicted sales, 110. Here's the standard error of estimation, 4.951. That matches with what we got, I think. Yep, there we go. And then our interval went from 98.583 up to 121.417. Yes, okay, we nailed it. Okay, so this is the confidence interval for the mean. And then this one is the standard error of prediction, 14.689. There we go. And our interval, prediction interval, went from 76.127 up to 143.873. Boom, there we go. Okay, so that's how to do that in Excel stat. Okay, so that's how you can do estimation and prediction with simple linear regression. Actually, one more thing. I'm going to come back to the output here. Remember, when we looked at this scatter plot in one of the earlier videos, this middle line was the regression line, but there's more lines on here. This one here, this kind of dotted one on both sides. If we look down here, that's a confidence interval for the mean. Okay, so that represents the confidence intervals that we were just talking about. So for example, at x equal 10, okay, from here up to here, that represents the interval that we calculated, 98.583 up to 121.417. Okay, if we were to go across here, that would be the 98 point whatever it was, and this would be the 121 whatever it was. Okay, and then the outside lines, that's the prediction interval. So again, if we trace this across and then trace this across to the axis, we would be able to get these numbers, 76 up to 144. Okay, let's just look at it again, see if it seems reasonable. Yeah, 76 would be in here, and then up here, whatever it was, I've forgotten already, 144. So if I'm doing x equals 10, and 144 would be here. Okay, so this is a graphical representation of the confidence intervals, which is the inner lines, and the prediction intervals, which are the outer lines. Okay.